Hello, guys. So we are going to discuss about the Charles Law. And the Charles Law. Charles Law is the second law that we are dealing with today because last meeting we discussed about the Boyle's Law. Such a recap, if we are dealing with Boyle's Law, we are dealing with the effect of volume and the effect of pressure in a constant temperature, right? In Charles' law, we are dealing with the effect of the temperature, such as Kelvin, to the effect of volume in constant pressure. Okay? Let me change the temperature into T para hindi tayo malito in order for us to be clarified regarding with our discussion. Okay, so we are in the Charles law. So this is our topic for today. And so Charles law is something to deal with the effect of temperature in the volume of the gas. For example, in the application of in the video that we have in our Google Sheet, the activity, the introduction of gas law, we all know that we use hot air in order to inflate the balloon, hot air balloon, in order for it to float. Because hot air have a what we call higher temperature, right? So the temperature of that air molecule is higher. Then thereafter, when we inflate the hot air balloon with the balloon with the hot air, its volume also increases, right? So in this regard, we have the direct relationship. Okay? This direct relationship contributed to another example. If we have a balloon, then the balloon is directly put into a sunlight. We all know that it will expand, right? Because according to kinetic molecular theory, na when it is when its volume is higher, or sorry, when the temperature of a gas molecule is higher, its kinetic energy is also higher. But when we put the balloon in a freezer with an ice, of course, the balloon depleted, lumiliit, because the molecule inside the balloon, its kinetic energy moves slower, produces slower energy. And thereafter, nagkakaroon ng depletion. And with that, there's a direct relationship between volume and temperature in constant pressure. So as to say that its expression can be volume over T1 is equal to volume 2 over T2. Such there's a direct relationship. If we have initial and final volume to the temperature of initial and final temperature. Set an example for this problem here is that, let's try to answer number 1. If a gas has a volume of 1.25 liters at a temperature of 300 Kelvin, what will the volume change to if the container is cooled to 200 Kelvin? So let's try to write our given in a table format para hindi tayo malito in order for us visualize our concept clearly. Okay? I am outside the classroom in order for us to have a fresh air in answering the problem, right? So we have volume and temperature. Make sure that the temperature in this problem is always in Kelvin because that's our standard unit for temperature. Okay? We have volume here. We have temperature here first and second. So the volume 1 at the initial is 1.25 liters and its temperature is under 300 Kelvin. For number 2 or final, we have 200 Kelvin and we are asked for this volume. So here we can tell that from the initial mataas yung temperature and bumaba siya, we are expecting that since the temperature goes down, the volume also goes down. So that is probably our main concern with their relationship. Okay? So let's proceed to identifying the unknown, which is the final volume. And we have the formula using our expressive equation. Okay, so we equate the problem in Charles' law as final or initial volume over initial temperature is equal to final volume over initial or final temperature. In our solution, or F, all we need is to plug in the given values. So for V1, we have 1.25 liters, and we have temperature starting with this problem. Okay, so all we need is to write 1.25 liters to 300 Kelvin equal to of course our velocity volume 2, which is unknown, divided by 200 Kelvin. We need to cross multiply. So 1.25 liters multiplied by 200 Kelvin is equal to volume 2 over 300 Kelvin. Next, 1.25 liters. Let me check my calculator. Okay, so for my calculator here, it's 1.25 liters multiplied by 200. The answer is 250. So we have 250 liters multiplied by Kelvin is equal to B2 multiplied by 300 K. We need to divide both sides of the equation by 300 K in order for us to get the value of final volume. Okay, so V2 is equal to 250 divided by 300 Kelvin. So the answer is 0.83 or 0.83, and the unit will be liters. So this is our final volume. And this is our answer. We all know from the previous data that it will become 0.83 liters. So as to say, correct, because as the temperature goes lower, the volume also becomes lower. So that's all, and that's the process on how we solve a problem involving a Charles law. Thank you guys, and have a good day.